Good day, students. Welcome to our lesson this week in General Mathematics. In this session, we are going to discuss deferred annuities. There are annuities whose payments do not necessarily start at the beginning or at the end of the next compounding period. A deferred annuity is a kind of annuity whose payments or deposits start in more than one period from the present. The period of deferral is the time between the purchase of an annuity and the start of the payments for the deferred annuity. For example, a certain fund is to be established today in order to pay for the 5,000 pesos worth of monthly rent for a commercial space. If the payments for rent will start next year and the fund must be sufficient to pay for the monthly rental for 2 years, how much must be deposited at 2.5% interest compounded monthly? So in this problem, the given are the following. The regular payment, which is 5,000, compounding period, which is monthly, so M is equal to 12. Time is 2 years. The interest rate is 2.5% or 0.025. The period of deferral is represented by K. K is equal to 1 year. And in this problem, we are looking for the present value. So look at this problem. There's a statement here: if the payments for rent will start next year and the fund must be sufficient to pay for the monthly rental. So take note, will start next year. So from there, we got the period of deferral, which is 1 year, because next year. So K is equal to 1. For the solution, we are going to use this formula. P is equal to R times 1 plus I over M raised to negative Km times 1 minus 1 plus I over M raised to negative MT all over I divided by M. So this is our formula to solve for the present value of a deferred annuity. So substitute the values of R, M, T, I, and K. We'll have P equals 5,000 times 1 plus 0.025 over 12 raised to negative 1 times 12 times 1 minus 1 plus 0.025 over 12 raised to negative 12 times 2 all over 0.025 divided by 12. So get the answer in the first part, those outside the bracket. 5,000 times 1 plus 0.025 over 12 raised to negative 1 times 12. So you'll get 4,876.6763 approximately. Okay? Or I think this is the exact result. Then for the items inside the bracket, 1 minus 1 plus 0.025 over 12 raised to negative 12 times 2 all over 0.025 divided by 12. So you'll get 23.38612,786, and multiplying these two will give you 114,046.58. So this means that the present value of this deferred annuity is 114,046 pesos and 58 centavos. Another example. Find the present value of a 2-year deferred annuity at 4% interest compounded quarterly with payments of 1,000 pesos made every quarter for 3 years. So this is an easier problem because it is obvious what is the period of deferral. It is already stated, which is 2 years. So this the given first. R is 1,000 pesos. The compounding period is quarterly, so M is equal to 4. Time is 3 years. The interest rate is 4% or 0.04. Then the period of deferral is 2 years. So K is equal to 2 years. So again, we will be solving for the present value of a deferred annuity. So again, we will be using this formula. Substitute the values of R, M, T, I, and K. So you'll get this. So the first thing to do is to get the result of the first part, 1,000 times 1 plus 0.04 over 4 raised to negative 2 times 4, which is 923.48322. Then get the result of the items inside the bracket, 1 minus 1 plus 0.04 over 4 raised to negative 4 times 3 divided by 0.04 over 4. And that's 11.2550747. Okay, and then multiply these two, it will give you 10,393.88. So, meaning to say, the present value of this deferred annuity is 10,393.88 pesos. So since the formula is long, just be extra careful in performing your solutions. Make sure that you are following the proper sequence in performing your operations, the order of operations. Example 3. Find the future value of an annuity 2.5 years after the last payment is made at 5% interest semi-annual payments of 4,500 pesos for 10 years. So here, we are now looking, or we will be solving for the future value. So this means that we are going to use a different formula. So the first thing to do again is to list the given. So R is 4,500. M is equal to 2 because the compounding period is semi-annual or semi-annually. Time is 10 years. Then I or interest is equal to 5% or 0.05. The period of deferral is 2.5 years. So K is equal to 2.5. So we are going to solve for the future value of this deferred annuity. For the solution, so just substitute the values of R, M, T, I, and K to this formula for the future value of a deferred annuity, which is A equals R times 1 plus I over M raised to Km times 1 plus I over M raised to MT minus 1 all over I divided by M. So get the result for the first part, 4,500 times 1 plus 0.05 over 2 raised to 2.5 times 2, which is 5,091.336958. Then for the second part, the items inside the parentheses, 1 plus 0.05 over 2 raised to 2 times negative 10 minus 1 all over 0.05 divided by 2, which will give you 25.544,65761. Multiplying these two will result to 130,056.46. This means that the future value of this deferred annuity is 130,056.46 pesos. Another example, regular yearly deposits of 10,000 are put into a fund for 20 years at 4% annual compound interest rate. If no withdrawals are made, what is the future value of the fund 10 years from the date of the last payment? So list the given first. R is equal to 10,000. The compounding period is annually, so M is equal to 1. Time is 20 years. The interest is 4% or 0.04. The period of deferral is 10 years because 10 years from the date of the last payment. Okay, A, or the future value. So this is the one that we will be solving for. So use this formula again. Substitute the values of R, M, T, I, and K. So get the result of the first part, 10,000 times 1 plus 0.04 over 1 raised to 10 times 1, which is 14,802.44285. Then those inside the parenthesis, the bracket, 1 plus 0.04 over 1 raised to 1 times 20 minus 1 all over 0.04 divided by 1, which is 29.77807.858. Multiplying these two will give you 440,788.31. This means that the future value of this deferred annuity is 440,788.31 pesos. Now it's your turn, so solve the following problems. Number 1, find the present value of a 3-year deferred annuity with regular monthly payments of 10,000 pesos compounded at an interest rate of 5% for 4 years. Number 2, find the future value of an annuity 2 years after the last payment is made at 2% interest compounded quarterly with regular quarterly payments of 5,000 pesos for 3 years. So in this case, the period of deferral is 2 and time is 3 years for problem number 2. For problem number 3, Mang Rudy, a jeepney driver, won a local lottery game. After reserving a portion of his winnings for his family's immediate expenses and the renovation of their house, he is left with 150,000 pesos. He decided to put this in an account providing 3% interest compounded monthly. He also plans to let the money earn for 5 years and then make equal withdrawals for another 5 years until all the money in the account is depleted. The question is how much should be his monthly withdrawal. So in this problem, you will be solving for R. Okay. And you are going to use the formula for the present value of deferred annuity. For number 4, as preparation for his retirement 20 years from now, Mr. Hernandez agreed to pay an insurance firm 20,000 pesos every year until his retirement in exchange of yearly pension for 25 years. If the insurance firm put the payments in an account providing 2.3% annual compound interest rate, how much yearly pension can Mr. Hernandez receive? So, in this problem, you are again will be solving for R, and this time you will be also using the formula for the present value of a deferred annuity. Number 5, instead of giving monthly allowance to Carl, his parents agreed to put an amount today in an account that gives 5% interest compounded monthly. However, Carl has his own savings, so he decided to make the first withdrawal 6 months from now. So that's the period of deferral, point 5. If the account must be sufficient for Carl to make 15 withdrawals worth 5,000 pesos each, how much must Carl's parents deposit today? Always remember, class, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy, and God bless everyone. See you next week for our next topic.